Hey guys, Mr. Bowman here. Today's learning objective is in blue. We are learning to calculate the expected value of probability scenarios. And then just a reminder from the previous video, this expected value idea is different to the expected number idea that we looked at earlier. So make sure you think about them as two separate ideas. So let's start off with, well, what exactly is expected value? And it actually starts off fairly similar to expected number, except the formula is going to be a bit messy. It's going to be x1, which relates to event number 1, and we're going to multiply that by the probability of event number 1 happening. We're then going to add on x2, and we are then going to multiply that by the probability of event number 2 happening. And we're actually going to carry this on. So we're then going to go plus, and I'm just draw some dots here. We keep doing this plussing motion until we get to the very end of our sequence. So that's when we get xn being the last one times the probability of x being equal to n. So it's a bit messy. So what we'd actually do is we've got potentially several separate expected value calculations to do, and we're going to add them all together. The other way of writing this formula, this little symbol here, that means sum of, and we're doing the sum of all of the x's times their respective probabilities. Calculations, there is a high risk of doing math errors. So during the next couple scenarios, I'm just going to draw some tables, which will help you break down the questions, it'll help you process the information, and it'll mean you're less likely to make some math errors. So question number 1, just put it up on the screen. If you roll a 5-sided dice, what is your expected value? And the table that I'm going to get you to draw up looks a little bit like this here. So this here is going to relate to x, and the x is all the events that could come up. So when we're rolling a dice, we could get a 1, we could get a 2, could get a 3, we have to carry on a bit more, could get a 4, or we could get a 5. We're then, in the next line of working, we're going to think about, well, what's the probability of the x occurring? And in our case, because this dice, I'm assuming it's a fair-sided dice, the probability of each of the outcomes is going to be 1/5. We're now going to draw another line, and we're just going to stretch our table down a little bit. And the next bit is going to be x times the probability of x. And that relates to the parts of our formula that I mentioned before. So we're going to go this number times this number is going to get us to this number. And we're going to repeat that for every column of the table that we drew. So this one over here is going to be 1/5. I might actually change them to decimals to make it a bit easier. So that's going to be 0.2 for me. Over here, that's going to be 0.4, 0.6, 0.8, and down the very bottom is going to be 1. Finally, we're going to do our calculation. So our expected value is going to be equal to the sum of x times the probability of x, and we've got that on our table above. It's going to be 0.2 plus 0.4, which is 0.6, plus another 0.6, which is 1.2, plus 8, 0.8 rather, which is going to get us to 2, and we're going to add on another one, which is 3. And if you think about this number, that makes sense because 3 is kind of the middle value, so it's almost acting as an average. I've now shifted over to our second question. We've got a raffle fundraising for a hockey tournament. Each ticket costs $5, and there's 100 tickets available, so that information may be useful. First prize is a $300 travel voucher. Second prize is a $100 petrol voucher, and there are 20 bonus prizes of a $10 food voucher. What is the expected value of buying a ticket? And the expected value will help you figure out if you should buy a ticket. If the expected value is greater than the $5 you put in, then it makes sense. It means on average you're going to make money for this. But if the expected value is less than that $5 ticket, you'll probably not buy that ticket. But given it's for a fundraiser, you normally don't mind a little bit of a loss, and that's kind of the point of these things, so they can fundraise their money. So the table's going to look a little bit different because last time we went down to x and then the probability of x, and then we went down to the probability x times the probability of x. But there's an extra layer here depending on what the prize is. So what I'm going to do is I'm going to start my table with the event. And the events that we have here, you could win the first prize. You could also win the second prize. You could win a bonus prize. And after that, I've run out of room here, but you could have no win, or most likely you're not going to win anything there. So that's what my table is going to look like, and it's going to resemble the graph that we had before. So X for the first prize relates to the dollar value that's attached to that prize. So in this case, the X here is going to be $300. The probability of me winning this X, well, that's going to be 1 out of 100 because there's only one prize for that first prize. And that means the probability, or X times the probability of X, that's going to be equal to 3, which is 300 divided by 100. Second prize, that's a $100 food voucher, $100 petrol voucher. So X is $100. The probability of me winning that X, that's also 1 in 100. And the probability times the X value is equal to 1. Finally, the last prize are these bonus prizes, which relates to those travel or those food vouchers. Each value is $10. I've actually got a 1 in 5 chance of winning that because there's 20 out of the 100 tickets available. And when I go 10 times 1 over 5, that's going to get me to $2. And the remaining case, if I don't win my prize or my X value is 0, because I'm not going to win anything at all, the probability of that happening, that's actually the 78 out of the 100 tickets. And P times the probability of X. So in this case, no matter what happens, if I don't win a prize, I've got a $0 value attached to that. So I've gone through all my calculations. So now our expected value for this case, as we said, is going to be equal to the sum of all of the X times the probability of X's. That's going to be 3 plus 1 plus 2 plus 0, which is equal to $6. So that means on average, you're going to win $6 from this prize, which is actually quite good value given it was a $5 entry fee. So what that meant is, in theory, if you bought all 100 tickets, you're actually going to win $600 for your $500 of value. Finally, question number 3, we've been gifted $1,000 from a relative, very generous. We've decided to invest it in the share market. When we made this investment, we're 75% sure that the market's going to increase. If the market increases, we're going to get a 15% return. If the market declines, we're expecting a loss of 5%. What is your expected value of this estimate? So we're going to start off fairly similar to the Raffle question. I'm going to describe my events, and the events here they're actually nice and easy. The market is either going to increase or the market is going to decrease. Now, X relates to the fiscal or the dollar values related to each of these outcomes. So if the market increases, we're going to have a 15% return. So we're going to have 1,000 times 1.15, which is equal to $1,150. If the market decreases, we're expecting a 5% loss. So that's going to be 1,000 times 0.95, which is going to be equal to $950. We're then going to move on to the probability of each of these events occurring. The increasing, that is 0.75, and the decreasing had a 0.25 occurrence. And finally, our last row of this table, it's going to be X times the probability of X. Multiply 1,150 by 0.75, and that there is going to get us $862.50. We then need to do the same with the other column, so that's going to be $950 multiplied by 0.25, and that's going to get me to $237.5. We are then going to find the expected value. So the expected value is equal to the sum of, well, that's a bad sum sign. I'm too OCD to leave that as it is. Sum of X times the probability of X, which is going to be equal to 826.5 plus 237.5. I'm just going to use my calculator to help me out getting those values. So we got 862.5, and we're going to add 237.5. Hopefully you did that with me. And we are expecting an $1,100 return from that. As this $1,100 return is greater than the initial $1,000 we invested, this is actually quite a wise investment decision. And the $1,100, it does make sense because most of the time we're going to make a 15% return, and a small portion of the time we're going to make a 5% loss. So a 15% return, that's quite a big return. That's balanced by 5% loss, which is quite a small loss. So it makes sense for us on average to make a bit more than we put in. So hopefully this expected value scenarios make sense. Hopefully you saw how I used a table to help minimize doing little math errors. Thanks so much for watching. Now let's get into heaps and heaps of practice.